Good morning, this is your Stats Sensei, Mr. Spensei, and this is Death Packet on chi-squared and regression. This is going to be chi-squared problems 131 through 137. So the campus bookstore at a local university is interested in finding out whether the textbook preference and the class level, freshman, sophomore, junior of the student are associated. Use the word associated. I'm thinking it's going to be a chi-squared test, a random sample of 100 students. All right, so we only have a single sample is obtained, and we have two variables, uh, class level and new books versus used books. The students are also asked whether class level freshman, junior, sophomore, senior, which of the following is appropriate test? Well, we know that we have one sample. We have two variables, and we're working with categorical data. Our answer here is chi-square test of homogeneity. They said associated. Chi-square test of independence. To be homogeneity, we'd have to have more than one sample. We'd have to have more than one sample. We only have one sample, and they also said associated, which was nice of them. But I trust more the fact that it's only one sample because it's only one sample, and we have categories one, two, three, four categories for that variable, and on one, two, three for the other. So in this case, we would have either a 4x3 or 3x4 matrix, and it's going to be a chi-square test of independence. 132, a study was conducted to investigate whether there are regional differences in peanut butter preference in the United States. The country was divided into 7 geographic regions, and each region, a random sample of peanut butter eaters were asked. Whoa. Each section had a random. We have 7 samples. Huh. As soon as I have 7 samples, that's multiple samples. That tells me this is probably homogeneity. All right. So the responses were summarized in a 7x2 table of counts for each combination geographic region. Oh, there we go. We have a table. We have multiple samples. As soon as in this case, we have 7 samples. If we have a table, it's probably going to be either homogeneity or independence. Well, in this case, we know we have 7 samples. As soon as you have more than one sample, that gets rid of independence. This is a chi-square test of homogeneity. All right, 133. The ecology club at a local high school um, took separate random samples of sophomores, juniors, and wow, look at that word, separate random samples. Homogeneity. To learn whether there are differences in attitude towards recycling by grade level. Students were asked to respond yes or no to the question, do you regularly recycle plastic bottles? The results were summarized by a 3x2 table of counts organized by grade level and yes, no. The club performed a chi-square test of homogeneity across the 3 grade levels. Which of the following could be an appropriate null? All right, so with a null, we're saying the proportions are the same. And with the alternative, we're saying the proportions are different. Okay, so in this case, HO, P1 equals P2, P3, where P1 is the proportion of samples sophomores that responded yes, P2 is the proportion of samples of juniors that, okay. Um, so that one sounds good. All right. But this says the word sample, and that's a problem. Our problem there is it says sample, because remember it's proportion of the population, because we're making claims about the population, not about the sample. So that gets rid of one. As soon as we get rid of one, C is gone, D is gone, E is gone. So let's look at two. There is an association. No, this is a chi-square test of homogeneity. This is homogeneity. That's wrong. There is no difference in the distribution of regular. Well, saying there's no difference is the same as saying they are the same. That's the same as saying the proportion. No difference is saying the same. The distribution is the same across the three grades. And as soon as we say they're the same across the three grades, and this makes this correct. And so our only choice on this one, on 133, is B. All right, 134. A forester reported the following distribution of tree types to a local logging company. Okay, there they are. The logging company generated a random sample of 100 trees and observed the following distribution. Awesome. The logging company would like to use it to sample to provide convincing evidence that over 50% of the trees in the forest are spruce trees. The logging company has decided to use a chi-square goodness of fit to justify the claim. Why is the chi-square goodness of fit not appropriate? Chi-square goodness of fit just says, hey, does our observed match the expected? So it's asking, does it match it? What they ask for is the logging company use its sample to provide convincing evidence that over 50%. Well, that would be going HO P equals 0.50, HA P is greater than 0.50. All right, that's what that would be. And you're like, oh, what is that? That's a one proportion Z test. So this is not, they're trying to, chi-squared is not appropriate for this. A one proportion Z test would be. Okay, and actually they could have done that and that would have worked. So let's take a look at this. A chi-square goodness of fit test would be used to show the entire distribution of trees in the forest is different than what the forester reported, not necessarily the proportion representing spruce trees. I like that answer. Let's see if there's anything better, but I like that because it represents distribution of the trees, not the individual proportion. Like that. The logging company should find the average number of spruce trees. No, because average would be an X bar, and we're talking about proportions. Okay. The logging company does not need to complete an inference procedure. Stupid response. In order to perform a chi-square, the logging company needs expected counts, not percentages. We can get the expected counts. I can run this and get the expected counts. I can add up all the trees that were counted and multiply by the percentage. We'd be good to go because this would be 52 times 100, 22 times 100. That was my sample size, so that's not an issue. The sample size does not meet the minimum requirements. There's not a minimum requirement on the sample size unless you're talking about the expected value. All right. And so this was not talking about expected value. The problem is the chi-square test is not appropriate because it's used to show the distribution and not necessarily the individual. So 134, the best answer is A. All right, moving on to 135. A chi-square test for homogeneity was conducted to investigate whether the four high schools in a school district have different absentee rates for each of four grades. The chi-square test statistic and p-value were 19.02 and 0.025. Which of the following is the correct interpretation of the p-value? Well, we need to talk about, first off, let's talk about what the ho and the ha are. The ho is the proportions are the same. The ha is the proportions are different. All right. So in other words, we're claiming that they're the same, and the ha is that they're different. Different. So let's talk about p-value. P-value is the probability of getting a test statistic this extreme or more extreme, saying given that the proportions are the same. All right. So there's a 0.25 chance that we get a test statistic of 19.02 or more given the proportions are the same. All right. So assuming that the high school has the same absentee rate, So that's given that it has the same rate for each grade level. There is a 2.5% chance, that's what that is, 2.5% chance of finding a test statistic 19.02 or smaller. No, that's wrong. It's 19.02 or larger. We need a larger. Assuming that each high school has the same absentee rate for each grade level, there's a 2.5% chance of finding a test statistic of 19.02 or larger. Like it, that's B. All right, 136. Which of the following is a reason not to take a chi-square test of homogeneity to analyze a set of data? All right. So the data consists of one categorical variable for two or more different populations. Well, two or more populations, that's two samples, one categorical variable. That is a homogeneity. And it says not to use. So this is a good chance to use it. So that's not my answer. The data were obtained through a simple random sample from a single population. Uh-oh. A simple random sample. One sample, not going to work. All right, we have to have multiple samples, which indicates multiple populations. We need multiple population because we have multiple samples. All right. Um, and let's continue on. So our answer choice is B, but the data were obtained from more than two populations. We like that. That's good. Four different regions. We like that. That's multiple populations. Using a simple random sample of a population from last year and a simple random sample of the same population from this year. Oh, we got two samples. Again, multiple samples. So everything with multiple samples is homogeneity. This was a single sample from a single population. Not going to work. That would be, we could look for an association and we could do a chi-square test of independence that way, but not of homogeneity. Finally, 137. A reporter intends to survey residents of a city to investigate whether there are differences in use of grocery delivery services by region where the city's work residents live, north, south, west, and east. As soon as I see that, I'm going, this is probably going to be homogeneity because it looks like I have four populations. All right, city residents will be asked to respond yes or no to the question, do you regularly use a grocery delivery service to purchase groceries? Results will be collected by a 4x2 table of counts organized by region and response. For a chi-square test of homogeneity, there we go. Thought it would be. Which of the conditions listed below is not necessary to investigate whether there are differences between use of grocery service by region? Row total times column totals times total will have to be greater than 5. That's just saying the expected counts have to be greater than 5. Got to have that. Data should be collected using a stratified random sample with region as a strata. That's a way of saying they say stratified is basically saying, hey, we are going to have four random samples, one for the north, one for the south, one for the west, one for the east. So we have we have a stratified random sample. I like it. All expected counts should be greater than 5. Hey, we said that in C. As we said that in A. So A and C are saying the same thing. The number of residents sampled from each group should be greater than 30. Wah, wah, wah. That is true for central limit theorem for t-test. Here, we just need to have large enough to have big enough expected values. All right? So I'm thinking D is going to be the one because it says not necessary. So I'm thinking D is going to be the one. The total number of residents sampled should be at most 10%. Yes, we can't exceed the 10%. We have to have that. That is a true statement. So our answer choice, the one that's not appropriate, is D, because this is for central limit theorem and applies to tests for means. All righty. Appreciate you watching. I hope this helped. Look forward to seeing you on the next one. Thank you.